Day 13 of 90 in the Java Challenge, and today we're tackling something that looks trivial but quietly breaks production services: input and output. Here's the demo that should scare you. I've got a Spring service reading an uploaded text file. Locally it works perfectly. I deploy it, upload the exact same file, and the response comes back as garbled question marks and Mojabake. The code didn't change. The file didn't change. So what broke? By the end of this video you'll know exactly why, and you'll never write a leaking charset broken read again. First, the mental model. Java I/O splits into two families. Byte streams, input stream and output stream, move raw bytes, images, zip files, anything binary. Character streams, reader and writer, move text, and critically, they decode bytes into characters using a charset. The bug in my demo? I wrapped my input stream in a plain input stream reader with no charset. That means Java silently used the platform default UTF-8 on my laptop, but something else inside the container. Same bytes, different decoding, garbled text. Let's walk the chain, because every wrapper has one job. You start with an input stream, raw bytes from the uploaded file. You wrap it in an input stream reader, and this is where you pass the charset: new input stream reader, input stream, standard charsets.utf_8. That converts bytes to characters correctly. Then you wrap that in a buffered reader. Why? Without buffering, every read hits the underlying stream one character at a time, brutally slow. Buffered reader pulls a big chunk into memory and serves your reads from there. Input stream to input stream reader to buffered reader, bytes, then decoding, then buffering. For files specifically, the modern NIO API does this in one clean line. Files.newBufferedReader, path, standard charsets.utf_8. That's it, it builds the whole chain for you with an explicit charset. The lesson here: always name your charset. The moment you write new file reader, file, with no charset, you've planted a time bomb that detonates the first time your code runs on a machine with a different default encoding. Hardcode standard charsets.utf_8 and the bug simply cannot happen. Now the second killer: resource leaks. Every stream you open holds an OS file handle. If an exception fires mid-read and you never close it, that handle leaks. Do it in a loop and your service runs out of handles and falls over. The old fix was a finally block, and people got it wrong constantly, calling close on a reader that might be null and throwing a null pointer exception that hides the real error. The fix is try with resources. Write try, open paren, declare your buffered reader inside, close paren, brace. Java guarantees close, runs when the block exits, exception or not. No finally, no null check, no leak. Here's the part most tutorials skip. Try with resources isn't magic syntax sugar that just looks nicer, the compiler literally rewrites it. Run javaup on your class and you'll see Java generated a finally block, a null guard, and even add suppressed calls so that if both your code and close, throw, you don't lose the original exception. It's writing the bulletproof cleanup code you used to write by hand, correctly, every single time. Any class implementing auto-closable works inside it. Let's settle a question you've all asked: scanner or buffered reader? Scanner is a tokenizer. It's brilliant for interactive input: scanner.nextInt, scanner.next, parsing typed values at a prompt. But for processing a CSV uploaded to a REST endpoint, scanner's delimiter handling around new lines gets quirky and slow. Buffered reader.readline is dead simple. It hands you one full line as a string, returns null at end of stream, and rips through files. Decision rule: scanner when you're tokenizing and parsing types, buffered reader when you're doing line-oriented I/O and back-end code. One last trap that burns people in containers: a scanner reading system.in blocks. It waits for input until end of file. On your laptop, you type and hit enter, fine. Inside a Kubernetes pod with no terminal attached, STIN never delivers EOF, so your thread hangs forever waiting on input that's never coming. If you genuinely need STIN in a service, read it on a separate daemon thread so it can't freeze your main logic, but honestly, Backend services should take input from files, requests, and queues, not STIN. Day 13 done. The takeaway: byte streams for binary, character streams for text, always name your charset, and always wrap reads in try with resources so a thrown exception can never leak a handle. That one habit separates a prototype from a service that survives production. Subscribe for day 14, we're going deeper into files and the Neopath API.